Welcome to section 4, and in this particular section we're going to take a look at some authentication basics and set this up in our application. And the learning goals for this is to implement basic authentication in our app and have an understanding of how we should store passwords in a database, how we can use inheritance in C#. And the reason for using inheritance is normally to avoid repeating yourself. When you hear the words DRY or the acronym DRY, this means do not repeat yourself, and there's certain techniques we can use in C# to help us avoid writing the same code over and over again. What we'll also take a look at in this section is how to use the C# debugger and how to go about getting information inside our code as the request is being processed and executed by our server. What we'll also introduce in this section is the concept of data transfer objects, what we want to send from our API down to our client, and also the other way around as well. We'll also introduce validation inside this section as well, and as part of the authentication, how are we going to authenticate the users to something like an API that we do not have a permanent connection with. Then we use something known as JSON Web Tokens, and we'll take a look at those in this section as well. On top of that, we're going to take a look at the concept of services in C# and also take a closer look at middleware inside here as well. And what we'll also take a look at in this section is extension methods. I said there's a couple of techniques in C# to avoid writing repetitive code, and whilst inheritance is one way, extension methods are another. So all of this is coming up in this section. But first of all, sometimes you might be thinking, I've got an idea for an application, but where do I actually start? Well, you typically start with the requirements. What should your application actually do? Now, we know we're building some sort of social dating app. And if you take a look at some typical requirements that would be involved in building an application of this nature, then a list of requirements might involve things like users should be able to log in, users should be able to register, users should be able to view other users, and users should be able to privately message other users. There's a certain word there that's used over and over and over again, and that's the concept of users. And this is where we start. We start with our user entity, and everything starts with the users in this kind of application, and then we build the rest of our app around this. So that's what we're going to start with, but what we'll take a look at next is what should we do with the passwords that the user uses to enter when they register or log in. And we'll take a look at that next. So what we're going to take a look at now is how we can go about storing something like a password in our database. Now, it goes without saying the worst thing that can happen to our application is that our database gets compromised in some way by some nasty hacker. And we need to consider that that's a possibility. So storing passwords in a database is kind of a big deal. How do we do it? Well, there's a few different options. Option 1, we could store the passwords in clear text, which is obviously a terrible idea, because if somebody does compromise your database and gets access to all of the usernames, email addresses, and passwords, then you've got a problem. And you then have to tell your users that, their passwords have been compromised and they have to change them. Now, whatever happens, you're always going to need to do that. But if you're storing your users' passwords in a database like this, then clearly that's going to be a problem. Now, a couple of our users in this database, you could say, well, they deserve to be hacked. And there are things you can do about that, which is to not let them use such a weak password in the first place. But commonly used passwords like that, there's not much you can do. If you do allow weak passwords and somebody uses a weak password and they get compromised, not your database, then that's really the user's fault. But we still shouldn't store the passwords in clear text. It's a bad idea, and we're not going to do that. So what we need to do is do something with a password. The user obviously enters their password in clear text. The password goes across the wire or the internet in clear text, but crucially, it's protected because we use SSL security to encrypt the data on the way from the client to the server. So we're fine with the users passing up their passwords to us in clear text. Now, option 2 is hashing the password, which means that we take their password, we add or apply a hashing algorithm to it, and we end up with a password hash. And we store the password hash in the database. Now, hashing is one way only. You cannot calculate from a hash what it was before it was hashed. So in theory, this is a pretty secure way of storing our passwords. But the problem with this particular method is that Bob and Tom have continued to use their weak password of let me in. But when we calculate the password hash, then the same algorithm is applied to the same password, which means we get the same result. Now, if our database gets compromised, then the attacker knows that Bob and Tom have got exactly the same password. And if he can somehow calculate the password from this, then he's got access to 2 accounts. It's very common for users to use the same password for different applications, no matter how much we're advised against it. And the problem with just hashing a password is that online there are dictionaries of every possible commonly used or combination of different passwords available, and their hashes have already been computed in various different algorithms. So what somebody would be able to do is simply take that password hash, paste it into one of these online dictionaries, and boom, they have your password within a couple of seconds. So this is also not a great way of storing a password. Simply hashing it is not good enough. When it comes to working out if the user's typed in the correct password, then we can simply calculate the password hash and compare it with the hash that we're storing in our database. And that's what we would do, but like I say, this is still not good enough. Option 3 is hashing and salting the password. Now, a password salt or a salt applied to a hashing algorithm is going to scramble the hash. So even though Bob and Tom have once again used the same weak password, notice that they now have completely different password hashes. There is no way for an attacker to know that Bob and Tom have got exactly the same password. Now, we're also going to store the password salt. Now, the password salt is another randomized string that we pass into the computed hash that then scrambles the hash in some way to make it very different to the original calculated hash, which is why Bob and Tom now have different password hashes. And then when it comes to working out if they've added the correct password when they log in, we simply need to calculate the password hash using both the password they've supplied and the password salt in order to calculate the scrambled with the salt password hash. Now, this is a better way of doing it, and for simple basic authentication, this is how we're going to implement it right now, because it's easy to implement, and 90% of the code that we write to do this is going to be fine for when we take a look at what we're going to do later on when we further secure the application. This is to show you the concepts of authentication, what we're going to do in this section. It's not going to be a battle-hardened, bulletproof solution, and you shouldn't expect it to be. This is one step above adding completely fake authentication. This gives you the concept of how authentication works in a very visible way that we code ourselves. And just to cover some frequently asked questions, why don't I use ASP.NET Identity? I will. It's coming later, and you will see how to use that, I promise. But ASP.NET Identity gives us all of the code that we can just use. It's magic, it's great, and it does a lot of the work for us. But it doesn't really show us how it works, and you end up with more questions about how does this work, how do I know this is secure, than if we do it this way. So we're going to implement some very quick and easy, simple authentication into our application to help us out. Which is why the second question, why are we storing the password salt in the database, is another one that I'm just going to answer with it's very easy to do, and it's not the way that we're going to finish up by the time that we complete this application. Because later on, as it says, we will refactor to use the widely used and battle-hardened ASP.NET Core Identity. ASP.NET Identity has been around for years, and it's commonly used in many, many applications. So it goes without saying that that's been tried and tested, and you can presume that's going to be secure. What we're doing now is kind of secure, but I wouldn't use it in a real-world application. And this is just a learning exercise to show us A, how authentication works, and B, so we have something to work with in our application as we build it. So that's the concepts of what we're about to do, and let's go ahead and now implement this. Okay, we're about to start implementing the setup for the password and login system that we're going to implement, the very basic one that we were talking about just recently. But before we get to that, it's time, or at least in my case, it's time to disable this hot reload feature. Just to review where we are. I've got my API server started, I've got my Angular application started, and if I go to the browser, I refresh, we're getting our list of users, and this is working because we're sending back the access control allow origin header. Now, with hot reloading enabled, which it is enabled, if I just scroll up here, we can see where I've used the .NET watch run command, and it tells us hot reload is enabled. And if I scroll down and I make a change, that should impact my client application in some way. And if I just go back to the program class, and let's just do the thing that caused us a problem before, and I'll change HTTPS to HTTP, and we get this hot reload of changes succeeded. If I then go back and refresh my browser, I should expect this to fail, but it doesn't. It continues to work, and it's sending us back the old, that has been updated, cause header. Now, this is going to lead to confusion later on, or as we're building our app, and I don't like this behavior where it tells us something has been updated, but it clearly hasn't been. Another annoyance that I have with hot reload, I'll just put that back to what it was before, is that not everything can be hot reloaded, even if it was working perfectly. If I go to another file, let's go to this weather forecast file. If you make a change to the name of a class, then hot reload is not able to accommodate this. So if I just add a T, then we'll get this prompt that asks us if we want to restart the app. Now, this always, if you stop and restart things, it doesn't always seem to work either. So you could be making changes, you think something has been updated, but it hasn't been, and this is no good either. Now, if we go and take a look at I'll just put this back to what it was as well, so I'd remove the errors in my app. But if we go and take a look at the hot reload support for ASP.NET Core, then it gives us some information on how we can disable the hot reload, and this is the approach I'm going to take in my demos. Now, if you're in the future, then possibly fix this and it's working, and maybe you'd like to keep it enabled. But do be careful if you do, because at the moment it's far from perfect, and it may cause you more problems than it solves, because if you think you've made a change and something isn't working as expected, then you're always going to have to restart the API server as your first troubleshooting step. But if we disable hot reload, let's take a look at this. Now, this is not working. Normally we'd be able to add this in the launch settings.json. I've tried this approach, it wasn't working for me, and somebody has enabled or created an issue in the .NET SDK repository, and at the moment this is just an open issue and it's just not working. At least it's not working for me. You can try adding this inside your launch settings. And if I go to the launch settings just to demonstrate the failure, or the fact this isn't working just now, and I add the property in here, hot reload enabled false, then I would expect not to see hot reloading inside my terminal. But if I just type in .NET watch, we don't need to add run, by the way, we could just use .NET watch to get this up and running, then what we saw there was that the hot reload is still enabled. So that hasn't been applied. So we cannot use, or at least I cannot use, that approach to disable this. But what does work to disable this, if we type in .NET watch and then just get a list of help commands for this, then we have an option to specify no hot reload inside here. And this is how I'm going to be using .NET Watch with the no-hot-reload. And if I press return, then this time it starts my app without hot reloading being enabled. Now the advantage of this, it goes back to using .NET Watch just as a file watcher. If I make a change, then it's automatically going to restart my API. So let's go back and take an example of that. If I just go back and do the same thing that I did before, but this time I've got just normal .NET Watch up and running, then notice that my application has restarted. It hasn't given me a prompt. It's not going to hold off from doing something to tell me that a rude edit has taken place or anything like that. It's simply going to restart itself. And with that change in place, if I go back and refresh my browser, now that change has been picked up and we can see the failure that we would expect. And if I go back and add that back in and my changes are saved, our app is rebuilt. So it is a little bit slower than hot reload, but it's a lot more reliable than hot reload is. So that's how I'm going to continue to use .NET Watch. I'm going to always add the flag from this point onwards. And I would encourage you to do the same, unless you're in the future and it's somehow working perfectly, then it would be better to have that quicker hot reload. But at the moment, it's highly unreliable from my personal experience. So let's get back to the actual purpose of this lesson. And we're going to add a couple of properties to our app user entity because we're going to want to store the password information as part of our user entity. And we're going to store these as byte arrays in our database. So we'll say prop, and then we'll specify byte array. And this one's going to be for our password hash. And in a second property, another byte array. And this one's going to be for our password salt. Now, anytime that we add properties to an entity, we need to tell our database that it needs to create a couple of additional columns to accommodate these properties. The way that we do that is by creating a new migration. So we'll open up the terminal, and regardless of hot reload or not, we always need to stop our API from running when we do such a thing. And then we can specify .NET EF migrations add, and we'll just say user password added as its name. We don't need to specify the output directory if we already have a previous migration created in the place that we want it. So I can just press return from this, and this should go ahead and create the new migration without any issues. If we go and take a look inside the data, inside migrations, then we can see our new migration has been created, and we get our migration class. And inside here, it tells us what it's going to create. It's going to create two columns. Now, even though we specified a byte array as the type of property, remember we're using SQLite, and it's Entity Framework's job to translate between the byte array that we're using in our class and what SQLite understands in the database. So Entity Framework, the SQLite package that we added earlier on, has decided that this should be stored as a blob, a binary large object in our database. That's fine. It's not our job to do the translation between our code and SQL. That's Entity Framework's job. So we're not going to worry about that. We're going to say, okie dokie, that's fine. And then we can go ahead and update our database so that these two columns get added. And the way that we do that, remember, was to use the .NET EF database update command, and this is going to apply the latest migration that we've just created. And if we take a look at the logs, then we can see that the table has been altered, and it's adding the password hash and the password salt properties. Excellent. And we can go a step further just for further reassurance and open up the SQLite database. And if we go to Solution Explorer and we take a look inside the database to our users table, we can see our two new columns. And if we press play, then our password hashes and salts are null because we haven't done anything to add those into the database. But this is what we're looking for right now. And in the next lesson, we're going to take a look at creating a base API controller and taking a look at how we can use inheritance to reduce the amount of repetitiveness there is in our code. Okay, in this lesson we're going to take a look at things we can do to stop us repeating ourselves so much in our code. And if we take a look at our API controller, for the users controller, we're going to create several controllers over the course of building this application. And every controller is going to need the API controller attribute. Every controller is going to need a root. And every controller needs to derive from the controller base class. Now, not every controller needs the data context. So we're not going to put that in our base API controller, but we are going to put the other elements inside here, and instead of deriving from the controller base, we're going to derive from our own base API controller. So inside the controllers folder, we'll create a new C# class, and we'll call it base API controller. And inside here, we'll remove the unnecessary using statements. We'll go back to our users controller, and we'll copy. We don't need the comment, of course, but I'll copy the selected text into my clipboard and just paste this in to our base API controller. Just need to add the imports or the using statements that are needed here. We need Microsoft ASP.NET Core MVC, so we'll add that in, and that applies to the root and the API controller. We don't need that comment, and we just need to derive from controller base. Now, if we knew that we needed the data context in every single controller, then we could also add this into our base API controller as well. And any derived classes that use our base API controller, if that's got a dependency injection for the data context, then our derived classes would also need that dependency, so it would also be created. But we're not going to do that for this one because this is not something that we would normally do and are not going to do long term throughout the building of this application. We're going to do something different rather than injecting the data context directly inside here. So because we're using a placeholder for the controller, then this is going to work just fine when we derive from our base API controller and remove this stuff that's inside our users controller. So instead of controller base, we can just say base API controller, and that means we no longer need the attributes at the top inside this class. And that's a very simple example of just using inheritance to save yourself from repeating yourself. And we could also, of course, update the weather forecast controller and take out the API controller attribute and its root. And of course, we could inherit then from the base API controller, and this controller should still work as well. So we've made a change and we need to test our changes working. And the way that we're going to test our API controller endpoints is to use Postman. We're not going to use our browser to do so. But in this case, instead of manually typing out each request as we create new endpoints, and we're testing more and more things inside here, to help us out and to speed up the testing of what we've done, I've created a Postman collection that we can use to speed up the testing of what we're doing in this course. And we can import this collection from the student assets folder into Postman. So we'll go ahead and do that and see what we get. And inside Postman, we can use the import button. We can choose the file we're looking for. I can select the version of the collection that I want to import and click open. Otherwise, you can just drag it in and that would be fine as well. And then it asks us, or it tells us what we're going to import, and there's a collection for dating app. I'm going to say import. And then we can get rid of our example collection that we were using earlier. So I'm just going to delete that to clean this up. And now inside here, we've got a collection of requests. And if we take a look at section 4 requests, when we've got a bunch of things inside here, but let's just go to section 2 and make sure that our API server is working as expected. So we've got our URL in here for the weather forecast controller. Let's just give this a go. And it tells us that connection is refused because I've probably not started my API server. Let's take a look. And sure, I didn't restart it after I updated the database. So let's just go ahead and use the .NET Watch no hot reload command and go back to Postman and try that one again. and we're getting a 404 not found. Why is that? Well, because we changed our weather forecast controller to use base API controller, and inside here we've got a root of API / controller, then that means in order to access this one we need to do the same. API / weather forecast, click send, and we get our weather forecast summaries. Let's just make sure the users is working. I'll click send on this one. We get our 3 users. This time we get the password sort columns in there as well, and if we try and get a single user and click send, then this is also working just fine as well. So we'll make use of this. I'll show you some good tricks you can use with Postman to speed up your testing of your work as we come across them and continue to build this application. And next on our list is to give a user the opportunity to register to our application, and we'll take a look at that next. Okay, so in this lesson we're going to give our user the ability to register to our application. To do this, we're going to create a new controller, and we're going to call this one account controller, and we'll remove the unnecessary usings at the top, and we're going to derive from our base API controller. Now once again we are going to inject our data context into this class, so we'll say data context and say context, and in my case I need to use API data, and then we can go ahead and initialize the field from parameter. Now inside here we're going to create an endpoint that the user can use to register. So this is going to be an HTTP post because we're creating a resource on the server, so we're going to post some information up, and we'll also specify the routes in here as well. So we have the, although we're deriving from the base API controller, so we've got our route which is going to be API / account because we get the controller placeholder from the first part of the name of what we've called this, and then we're going to specify register. So in order for a user to access this endpoint, it's going to be API accounts / register, and as long as they're making a post request, then that will get them to what we're doing inside this endpoint. Now we'll use our public async methods, and we're going to return a task of action results. And for the time being, and this is not how we'll do it going forward, but we're just going to return the app user to confirm that what we've done has been created, and then we'll see the newly created user in the response along with the password hash and salt that we're also going to create in this method. Now we'll call this method register, and we're going to take 2 properties inside here, or 2 arguments or parameters inside here. We're going to say a string of their username that they want to use, and also the string of the password they want to use. Now we need to take this password, which is just a string in plain text. That's how it's going to be sent up to our API server, and we need to hash this password using a hashing algorithm. Now we're not going to create our own hashing algorithm because that would be highly complicated, but a .NET framework provides us with classes that we can use to do just that. And the one that we're going to use is called HMAC, and let's go ahead and use it, and then we'll explain what we're doing as we go along. Now I've specified using, the keyword using here, which we'll talk about soon, but we're going to say using HMAC equals, and we're going to create a new class which is HMAC SHA 512. And if we hover over the HMAC SHA 512, this just initializes a new instance of the HMAC SHA 512 class with a randomly generated key. Now that randomly generated key is what we're going to use as our password salt. And why did I use this using keyword before I created this variable that stores this class? Now when we create a new instance of a class like we're doing here, then that's going to consume some space in memory. Now being the good developers that we are, once we're finished with this class, we'd like to dispose of it. And if we want that to happen automatically, then we can specify this using keyword in front. Now, in any framework, so like .NET, for example, there is such a thing called garbage collection. And every now and again, the framework is going to come around, take a look at any unused classes that are still residing in memory, and dispose of them. But we don't have any control over the garbage collector. And if we know that we don't need this class after we've used it, then we can dispose of it ourselves using this using statement. Now, if we go and take a look at why we can use this using statement, then if we go and take a look at what this class we're using implements, if we go to the definition, and this one just tells us our constructor here, and if we go up, we can see that this is deriving from the HMAC class. We'll go to that definition, and this is deriving from the key hashed algorithm class, and if we go to that definition, we can see that this is deriving from the hash algorithm, so we'll go up again, and the hash algorithm, which we're deriving from eventually, implements the iDisposable method. And if any class implements this iDisposable interface, then they have to implement a dispose method. And inside here, we'll see that there is, somewhere in here, it's quite a big class, so I've got to come down a fair way. But inside here, we can see that they're implementing the dispose method. So by us using the using keyword back in our account controller, then when we've finished with this class, then that dispose method is going to be called and the class is removed from memory. So now we have access to this class. In our register method, we're going to create a new user. So we're going to say var user equals new app user, and then we just need to specify its properties. So we can open some curly brackets, and we can say what we want our username to be, which is going to be the username we receive in the parameters. We'll also specify the password hash, and we need to calculate the hashing algorithm from our password. And we can use our HMAC class to do that. And inside here is a method called compute hash, which we'll use. And then inside here, because our password hash is a byte array, we need to get the bytes, or the bytes array of this computed hash. So we use encoding, and then we'll specify UTF-8, and the UTF-8 method has a getBytes method, and inside here we can pass through our password and add a comma. So we can see that this compute hash returns a byte array, and that's why we get no complaints, because our password hash is expecting it to have a byte array that we're going to assign to it. And then we can specify the password salt, and the HMAC class comes with a randomly generated key, so we're going to use that as our password salt. Then we can go ahead and use our context and users.add method. And this, at this stage, is not doing anything with a database. All this is doing is simply tracking our new entity in memory. And we're telling Entity Framework that we want to add our user, but in order for our database to do such a thing, we need to use the await keyword and say context and save changes async. And because we've specified we're returning an app user in this method, we can say return user. Okay, and now we're ready to go test our work. And this is going to fail. I'll just set the expectations straight away. And I'm just going to say force close all tabs. I don't want to save any of my changes in there. And we've got a method here to register the user. Now, a couple of things to point out. Instead of the full URL here, we've got a URL variable which is set to the URL of our API. And where's it getting this information from? Well, we can see the scope is the collection. And if we click on our collection and we take a look at the variables inside here, then we can have variables that we can specify for a collection, as we have in this case, and it's going to get the value from here for our URL, which matches what we're using for our API URL anyway. Now, if I try and use this method, this account register method, and click send, then we get a 404 not found. Well, we know we've just created this endpoint. So why is that happening? Well, regardless of what method you use for your API server, whenever we add something like a new controller, even if we're using .NET Watch and it knows we've made a change, it doesn't pick it up, and we have to actually stop our API controller and then restart it again. And now we're good, and if we go back, then we can hit the send button once again. But let's take a look at what we're doing and what we are sending up to our API controller. So inside the body, we've got a JSON object with two properties, the username and the password. And if we click send, let's take a look and see what happens. Well, we get a value cannot be null, parameter s. And it's telling us it's coming from account controller line 22. Now, if we go back and take a look at what we are doing on line 22 in our account controller, let's just close the other tabs to the right. On line 22, we're creating our new user. And what is that parameter s? Well, if we take a look at the getBytes method, then this is expecting a string of s as the parameter, and we're trying to pass in password, but our password isn't getting passed to this method. And that's because inside our register method, it doesn't really know where to get the password from, even though we've specified this as arguments. If we take a look at what we're sending an object, and inside our API controller, this is not an object, this is just two separate parameters that are both strings. Now, our API controller attribute, one of its powers is its ability to automatically bind our controller to the arguments in the method. But it's not doing that in this case. And there's a few conventions around this, and one of the conventions around this is that if this is a query string, as in a query string says that our username equals whatever, Dave in this case, and then we have an ampersand and our password equals pwd, for example, then our API controller is going to automatically bind to these two strings because a query string is not an object and it's capable of binding to these two arguments. And if we go back, there's another request inside here for registering a user with a query string. And we've got our API account register username equals Sam and password equals password. Now, in theory, this one should work. And if we click send, this time we get success. We get the user created, username Sam, and then we've got our password hash and our password salt. So that one works just fine, but we don't really want to pass up our username and password in a query string in this way, just to accommodate the API controller. We do want to actually send it up in the body of the request as we're specifying here. But before we fix this, what we'll take a look at next is using the debugger to help us understand what is happening as our endpoint receives this request and tries to process it. And we'll take a look at that next. Okay, in this lesson we're going to take a look at how we can attach a debugger to the process that's running our application so that we can inspect what's going on when we hit this particular endpoint and take a look at what we have inside these variables, for instance, take a look at what's going on inside this controller. And a debugger is a very useful tool in .NET as it allows you to see what's happening inside a method as it goes through the process of processing the logic that we put inside here. Now, this is a very simple method, so there isn't going to be a lot to see here, but the purpose of this is really just to show you how to start the debugger, and there's a couple of different options for this. Now, the first thing to do when you want to debug something is to tell our application or to tell the debugger where you want it to stop. And we want to stop the execution of our request, for example, on this line 20 in my case. And when we make a request to this endpoint, then the idea is that the debugger is going to stop at this point in the execution of our code, and then we can see what's happening from there. So when we earlier on added the assets for debug inside VS Code, we had this .VS Code folder created for us, and inside here is a launch.json. Now, if you're not seeing this for whatever reason, then come up to the command palette and look for .NET generate assets for build and debug, and that will generate the launch.json that I was just looking at here. Now inside here we've got configurations of how to launch our debugger. And we've got two. We've got one that's called Launch, or given a name of .NET Core Launch Web. And to use this one, we need to stop our API server from running. And we can use this to launch our process with the debugger. And we've got a second configuration, which is called .NET Core Attach, which allows us to attach a debugger to an already running process. So first of all, let's add a breakpoint. And we've got a breakpoint on line 20. And if we go to the debugging tools here, then we've got our options to whether we want to launch or attach. And I'll just go for the launch one first of all, because this one should always work. And if I open up the terminal, I do need to stop the application from running to make use of this, because it's going to start our application and attach a debugger at the same time. So I'll just hit the play button, and this is going to be the same on Windows and Mac, by the way. And it should just work. And we have our debugger running. We've got all of this noise in the debug console. We don't need to see that. What we're interested in is what's going on the left-hand side in this variables section. First of all, though, we need to make a request to this endpoint. So I'm going to go back to Postman, and I'm going to repeat the failing request. Now, we already know what the problem is, so there's no genuine purpose to using the debugger at this point because we already know what the problem is. This is just showing you how to use the debugger. So I'm going to click Send, and what this should do is stop at where we have our breakpoint. Now, what might have happened, as has happened to me somewhere in the background, is I've got a prompt coming up asking if we want to give .NET access to something. So I'm going to have to enter password information and say always allow. And this connection got reset. So let's try that one more time. And this time we get taken to our breakpoint and our execution has stopped. So when you first run this, you might get some security prompt asking you to do something which you need to enter password information for. Now, that was Mac specific. I've got a Windows equivalent over in this window. And let's just do the same in Windows. Make sure that we're all singing from the same hymn sheet and things work as expected. And inside my terminal, have I got the app running? Yes, I do. So I'm just going to stop the app, clear the window, and going to do the same again. I'm just going to go to the play button and launch the debugger and press play. And this should go ahead and launch my application with the debugger. And that all looks good, and it's going to open up my browser. Don't really care for that. And we'll go to Postman, and we'll execute this very same request in Windows this is. And that's sent, and if I go back to Windows, then we can see that we have indeed stops on this particular line. Now, I'm not going to go through debugger just yet. I just want to show you the alternative way of running the debugger, which is how I'll typically use it for the rest of this course. I just wanted to make sure that method worked first of all. Now, the way that I'd prefer to use the debugger is to already have the application running, and I'll point out a warning straight away. This does not work at all with hot reload, this debugger. It'll always ask you to stop and restart the application if you've made a change and then you try and attach a debugger to the process. It never works. Maybe in .NET 8 or .NET 9 that facility might be available, but for what we're doing we need to use the no hot reload for .NET Watch, which is what I'm using anyway, so that's no big deal. Now, this is Mac specific. You're going to see something slightly different on Windows, which I'll demonstrate very shortly, but this time we'll go for .NET Attach, and this is going to allow us to pick a process to attach the debugger to. So I'm going to click the play button, and then it gives us a list of things. And this is where students in the past have run into issues attaching the debugger. It's not the most intuitive of systems, I grant you, but we want to search in here, select the process to attach to. My API project is called very simply API. That's what I want to attach to. Now in this case it's just showing up as API. Sometimes it shows up as API run for whatever reason, but my project is called API. I've got API in my list of things, and I'm going to click this one to attach to it. And if I go and take a look at the debug console, then I should find that my debugger has started with all the noise inside there that we don't need to look at. And if I go back and repeat the request from Postman and I click send, then this takes me to the breakpoint as we would expect. Now on Windows, to do the same thing, once again I'll just go to the terminal and exit out of whatever that was, and I'm going to execute .NET watch, and I need to specify no-hot-reload and press return. And the application is running OK. Now in the case of Windows, we're going to say .NET Core attach, press the play button, and we want to select the process to attach to. Just going to search for the same thing. It just shows up slightly different on Windows. For some reason students have had issues with this in the past, but we're looking for API.exe. Windows uses executables, Unix-based systems do not. So on a Windows system we're attached to this executable, and this attaches the debugger. And if I go back to Postman and once again make the same request, then I should find that I've stopped on the breakpoint here. Now for the rest of this lesson I'll go back to the Mac to continue talking about the debugger. Now we've stopped on this particular line, and on the left hand side we can see the variables that are in use. When we see lists, lists is referring to our API controller as a whole, listing. Now inside our API controller we've got access to all sorts of goodiness inside here. We've got access to our HTTP context, we've got access to our request and the response when it's written and goes out, although we will not see that inside here, but a response is part of the controller properties. We can also see data about the route, and if we take a look at the values inside here and the values, then we can see that we've gone to the register or account register endpoint. And that's all well and good. I won't go into much depth about this because there's a lot of information to get from here. What we're interested in is the username and the password. Now because we've moved past the arguments and we're on the next line, then if our string of username is null or our password is null, then we're going to run into a problem when we try and use these. Now we don't run into a problem here because our username is allowed to be null. We're allowed to assign a username of null to our username. Where we get the problem is in this line here, the password hash, where we attempt to get the bytes, because this method, if we do not provide this argument or we set this to null, then we see that null reference exception. So typically what we'd do is we'd step over our code and check the values as we go through this, but we're only going to be able to go through one more time, as after we execute this line of code, that's where we run into the exception and that's where we fall over. So if we click this, this refers to step over, so we step over this line of code and we go on to our next line of code. Even though this is over 4 lines or 5 lines, this is one line of code because we've got our opening braces and our closing braces. So if we attempt to step over this again, this is where we run into a problem. Sometimes you might want to step into a method, and not really possible on the code we're looking at now because we don't have any methods inside here and we're going to fall over before we get to this point. And then we've got an option to step out of the method, and also the play button will just continue to the next breakpoint or the end of the request. So if we step over once again, this is where it falls over and we get our exception. And the request is finished now because it's sent the response back to Postman and we don't get any further information in the debugger. So this is just a very brief run through of using the debugger. If we want to detach it, then we could use this button, and we don't need to keep that breakpoint hanging around, so I'll just remove that as well. Now consider the debugger a tool in your toolbox. You don't need to use it every time you see a problem. In this case there was no need because our error was good enough to tell us which line was causing the problem. It tells us which value we were trying to access that cannot be null, and in this case the parameter was s. And if we take a look at what we're doing inside here, then what is using a parameter of s, and if we hover over that get bytes, then we can see that this is trying to use a string of s, and because s is null, That's why we get the exception. And specifically, if we do not provide that, this is the exception that it gives us, an argument null exception. And we can see that here. So it's not always necessary to use a debugger, especially if you've got good information about where the problem is occurring, because an exception is often good enough to tell you exactly which line of code caused the problem and what kind of problem that was encountered. So in the next lesson, we're going to take a look at how we can send up this in the body of the request to our API controller rather than using query strings. And that's coming up next. Okay, in this lesson, we're going to take a look at the concept of DTOs, or data transfer objects. And the data transfer object is basically an object that's used to encapsulate some data and send it from one subsystem of an application to another. Now, we've got our client as, let's say, that's one subsystem, and we want to send an object up to our API endpoint, which would be another subsystem, so that we can register the user by using this data, but not as two separate strings, but in the body of the request in Postman. And if we look at the register user, then we want to send up this in an object. And in order for our API controller to bind to that object, then this has to be an object. And that would be one reason to use a DTO, is so that we can get data from the body of a request. Another reason would be if we go back to Postman and look at what we returned as our app user. Well, we can see that we're returning the ID and the username, they're fine, but then we've got the password, hash and salt, and I don't think anybody would ever suggest that returning that data is a good idea. So of course we would not want to send that back. So using a DTO allows us to create a different object and just send back the properties that we're interested in. And there's other reasons that we'll look at soon when it comes to relationships, and we're getting data from two different tables and relating them together. Then we can flatten that data into a DTO object and just return that. All of that's coming up later, but for now we'll just need to use them so that we can get the object and bind to this object when we send this up in the body of our request. Now, to do this, we'll create a new folder in our API and we'll call it DTOs, and inside here we'll create a new class and we'll call it register DTO, and press return, and let's remove the unnecessary usings. Inside here we're going to create two properties, one for the string of the username and one for the string of the password, just as we have in our account controller as the properties we want to receive from our users. Now, we're not doing any defensive coding inside our register method at the moment. Currently, we can take a username that's null, and that's no good. And also, if a username tries to register with a username already in our database, there's nothing in place currently to prevent that from happening. So we're going to add some improvements into our register method, and we're going to check to see if a user exists before we allow them to register that username. And to do that, we'll create a private method inside here. That's going to be an async task. We want this to be asynchronous because we need to go to our database to check to see if that user has already registered. And we want to return a Boolean because our method is going to be called user exists, and that's going to return true or false. Does the user exist? Does the user not exist? And we're going to take the string of the username as an argument for this method. Now we're going to need to go to our database and we're going to return, or effectively we're going to return a Boolean from this. So the method that we'll use, we need to say await because we're using an async method. And then we'll say context.users, and then we can use a method called anyAsync. And this asynchronously determines whether a sequence contains any elements. And our sequence in this case is our users table. Does this contain any of the same username? So we'll say any async, and then we'll pass in, and it's very common for developers to use shorthand here for what the thing is that we're passing in, but in this case X refers to our app user. Because we're in our users table, we're using the anyAsync method, then X is going to refer to a user in that table. And this is effectively going to loop over every user to determine if what we're looking for exists. And we're looking for the username here, and we want to check to see if this is equal to the username that we're being passed in. So if this returns true, as in there is a user that has a username already in existence in our database, then this is going to return true. If the username does not exist, it's going to return false. Now we can use that inside our controller method, the endpoint, and we'll do this straight away. We'll just check immediately if this username is already in use. And we'll say if await, and we can say user exists to call our method. And we're going to start using our register DTO instead of these two strings. So we need to take these out and pass in our register DTO, and we'll call it register DTO. And then we can check the username that's inside that object, and we can say register DTO.username. And if this method returns true, then we're going to return a bad request, and we'll say return bad request. And we can pass in a message into this as well of what the error actually is. And we'll just say username is taken. Now, we don't know if they've used uppercase lettering or lowercase lettering inside the register DTO, because this is information coming from the client. So it would make sense for us to compare like for like. So we're going to make our username that's passed in to this method, we're going to convert this to lower, and we're going to compare like for like basically. And if we're checking the username to lower down here, we want to make sure that when a user does register, then we save their username in lowercase as well. It's very easy to get caught out with different casing because all the languages we're using, all two of them, are case sensitive. So inside this method, we check to see if the user exists. If the user does not exist, or the username does not exist, then we create our new instance of the HMAC class. We'll then go about the business of creating our app user. And when we set our username, we'll take the opportunity to say username to lower. But we're getting our username now from the register DTO.username, and we'll say to lower, so that our username is saved into our database in lowercase. So when it comes to comparing, then we're literally comparing like for like. And the password, of course, will come from our register DTO.password. And the rest of this for now can stay the same. Now, one of the powers of the API controller attributes that we get from our base API controller is that it automatically binds to the objects that we have inside our method here. And in order for it to automatically bind to the register DTO, then the property names need to match exactly with what we have in our register DTO, with what we're sending up in the body of the request, and what we're sending up is username and password. Now, because this is JSON, this goes up in lowercase. And our API controller receives this as JSON. It knows that JSON conventionally uses lowercase. So even though our register DTO is using uppercase username and uppercase password, then it's going to be able to bind to those properties inside there. So let's check. Let's go ahead and add the breakpoints to the first method inside our register, and we'll start our debugger and just see what's going on so that we can see the difference between this request and what we did previously. So we'll go to the debugging tab, and we're going to attach our debugger. I'm going to search for API, select this one. The debugger starts, and we can go across to Postman, and we can repeat the request that we had previously to register Bob. Now we've already got Bob in uppercase, I believe, in our database, so we'll use a different name for this, and I'm just going to say Jim as the name that we're going to try and register. So I'll click send, and we get taken to our debugger. Now the first thing to look at is this register DTO variable. This is what we're getting here, and if we look inside this, then we can see that password and username are both set correctly, password being password and username being Jim. So that part has worked successfully. So we should be able to move down now and go through the rest of the steps inside here, if we step over, we go and create our HMAC class. Then we attempt to create our new user. This time we should have we do have the password, so we can create the password hash from this. So we'll step over, and that's successful. Next we take a look at our context and we add a user. This does not save it to the database yet, so we'll step over this, and then we go and save our changes into the database, step over again, and we're going to return our user object. So if we step over and step over again, that technically completes the request. So I don't want to go into what Entity Framework's about to do with saving our user into the database, so I'm going to click the play button to complete the request, and if we go back to Postman, we find that Jim has been created successfully, which is exactly what we're looking for. What we should also find is that if we try that request again with the same user and click send, then we go to our first method, does the user exist? Now, if it's one of our own methods, we might want to step inside to step through the code in that method, and we can use step into, which is going to take us to our user exists method, and then we can step over this, although there's only one line, so there's not really much to see there. But we'll step over that, and we can see that we've gone to the return of the bad request, which meant that this particular method returned true. So we go to the bad request, and this is the response we're going to be sent. So if we click play, and we'll go back to Postman, we can see that the username is taken. And if we try and register Jim with a capital J and click send and just go through it one more time, we should also find that because we're converting everything into lowercase, then this also returns the bad request, the username is taken. And the bad request is given a status code of 400. It's considered a client-side error because we're doing something from the client side and the server's returning that response to say, hey client, this username is already taken, cannot use it, and they'll need to choose something else. But what will be allowed is if we do this and send up an empty username, then that's going to be allowed, and that's because we haven't introduced any kind of validation. And we're going to take a look at validation next. Okay, in this lesson we're going to take a look at validating what we receive from our clients. And currently, what we have the facility to do, if I send this request with an empty username, then there's nothing that's going to stop that from being accepted by our API, and now we've got some bad data in our database. And if I send this again, this time we get username is taken, but it's just an empty string as the username. So that's not good. And it'll probably be the same for the password as well. If I send this, then actually no, we can't because I've already used the username. So regardless, but we're not really doing anything to validate either of these fields. Now, there are different levels of validation, and earlier on I asked you to turn off this nullable flag. And if this is enabled, then this automatically makes string properties required, and that would feed into our database migration as well. And inside our migration, where we've got our initial create, then this column where it's nullable would be set to false, and then the username would be required at the database level. So that could be an approach that you want to take. There are alternatives to this though than using that nullable flag. What we could also do is in our entities class, where we've got our username, we could specify that this is required. If we wanted that to go down to our database level, I've got funny looking colors there. I'm just going to reload the window to see if that fixes the issue. That's better. So if we have the required property here, we create a new migration, then in theory, our username property, our column, would be updated. And let's just test the theory on that. And I just need to stop my API server from running. But in order for that to take effect, we need to actually add a new migration to update the database schema. So if I say .NET if migrations add and say username required as the name of the migration and press return, then this goes ahead and creates that new migration. And sure, we get an operation that may result in the loss of data, but let's take a look at what this did for us. And if we go and take a look at the new migration, then we've got an operation to alter the column, and we have a nullable property now of false, whereas the old nullable was true. So that's how we would add validation at the database level. Two options really. Either leave the nullable enabled, or you could set the required property inside the entity class, the app user class, and do it that way instead. I'm not actually going to do it that way. I just wanted to demonstrate how you could do it that way. We're just going to keep things as simple as possible, and we're going to have validation at the DTO level, and I'll explain why. But first of all, I've carried out an action that I want to undo. And if we want to remove a migration, and we can only do this before we've applied it to the database, so I didn't carry out a database update, but what I can do then is say .NET EF migrations remove, and this is going to remove the latest migration that I added. And sure enough, the migration has now disappeared, and we're back to how we were. And I've got this I do not need, so I can remove the unnecessary usings from my app user class. So another place that we can do validation, and this is the way that we'll approach it at this stage of the course for what we're doing right now, is at the register DTO level. Now this is quite a good place to do it actually, because inside our controller, inside our base API controller, we've got this API controller attribute. It's got a couple of powers. One of them is its ability to automatically bind to our parameters inside our method. And we've seen that happen. We didn't need to do anything special to make that happen. In the past, before the API controller attribute was available, then we'd need to tell the framework where to look for the thing that we're passing up to our controller. And the way that we would do that is to add an attribute, and we'd say from body. And then our controller would know to look inside the body of the request to find out what it is we're passing up to it. But we don't need to do that with the API controller attribute. Another thing the API controller attribute gives us is it's automatically going to check validation before we even get to our API controller. Now, if we go to our register DTO, and we're going to do the same thing that we did in the entity, we're going to specify that this is a required property, and we'll do the same for the password as well. And we're keeping things simple. There's many options with the data annotations that we can add to our properties. If, for example, we wanted to check that a phone number was a valid number, we could use phone. We can also use maximum length properties. We've got string validators, and we've also got the ability to add a regular expression. If none of the out-of-the-box validators are good enough, then we can create our own using regular expressions. We're not going to get into that right now. We're just going to say that both of these properties are required, and we need to make sure that our API server is running to test this. I did stop mine. So let's go and run this again. Note that I'm sticking to the no hot reload policy, because that's going to not work as intended at the time of recording. And my application started again, and if we take a look and we make this same request again now, then what happens is we get a validation error. It's a 400 bad request, it's a client-side error, and it tells us that one or more validation errors occurred. And we've got a trace ID, and then we've got an object called errors that provides an array of the different errors. And if I was to remove the password from this request and send this, then we would see two different errors, one for the password property and one for the username property, and what it is that we failed on. So that's our validation. But if we just go ahead and just take a look at what happens if we add our, well, we've still got our breakpoint here. Now, based on what I've said about our API controller attribute, then we should not hit our breakpoint if we fail validation, because I've said that our API controller attribute is doing this before we even get to our controller. So let's fire up the debugger one more time, and I'm just going to attach it to the process that's already running. I'm going to search for API. I'm going to select that one. Debugger is running, and if I go back and try and make this request again, then it returns the validation error, and I have not hit my breakpoint, so we have not hit this controller. And just to further prove the point, if I go to the base API controller and comment out this API controller, then we're going to have two things that go wrong this time, in theory. First of all, the registered ETO, our controller now is not going to be able to bind automatically to this. And if I make sure that my application's restarted, if I try and register a valid user, let's just say a name that I haven't used yet, let's say Sarah, and let's just say password. And we'll make this a valid request. I just want to see if this is going to bind automatically without the API controller attribute. And we get an internal server error with some object reference not set to an instance of object. So if we wanted that request to work without the API controller attribute, then we would need to tell our controller where to find the object. So we'll say from body, just to prove a point really is what we're doing right now. So the server has restarted. I'll resend this request, and this time it's valid and we get the response. Now if I take out the username, then I get username as taken. But what we've not done here is carried out any validation. Because I've removed the API controller attribute. Now if we wanted to do validation without that attribute, we'd need to take care of that ourselves. And once again, I'll just start the debugger because we will hit our breakpoint this time without that API controller attribute being available. So I'll just say attach and restart the debugger, search for API and go and start this again. Then head back to Postman, and this time we should indeed hit our breakpoint. And we do, because the API controller attribute is no longer taking care of any validation. Now, if we wanted to do this manually ourselves, then inside our API controller, we have something called model state that we can see here. And in here, we've got an error count of 1, and then we can see the key and the results, and we've got the string of username for the key. And if we look at the values that are assigned to this key, then we're going to see that the model state entry and the errors, and if we select this one, then we can see the same error that we saw earlier on, the username field is required. Now if we didn't use the API controller attribute, we'd need to go into our code and we'd need to check this value, we'd need to check our model state to see if there's any errors inside, and then we'd need to create our own validation response that we send back to the client. But we don't need to do any of that because our API controller attribute takes care of that stuff for us, which is really good. So I'm going to put that back. I don't need to have this from body, of course, because we know it worked before. I'll go back to the base API controller and uncomment this API controller attribute, and everything's back to how it was. And we're also validating our request at this level, the DTO level, and our API controller is taking care of it for us before we even get to our API endpoint. And just to prove things are back to working again, I'll just click on send, and we've got our validation error back. Nice and easy to carry out validation on an API server, in .NET at least. So now we're validating our requests. What we'll take a look at next is how a user that's successfully registered can log in to our server. Okay, so we've now got registration and validation. Our next task is to set up the login endpoint so that a user can pass us their username and password, and then we can check their password. And if their password is valid, then we'll give them an OK response. Now this doesn't mean that they're logged in, because when we use an API server and a client in this way, our client does not maintain a session with our API server. There's no state remembered between what our API server sends back and what our client has. It's stateless, an API server. And a REST API, which is what we're creating, is designed to be stateless. Our API server, it's not its job to remember a session that a client has or whatever the client is doing with the API. The API server's job is to receive a request, do whatever logic that request requires, and return a response. It's not required or designed to save that response. There's no state involved. So in this case, we'll let a user log in, we'll check their password against what we have in the database, and we're simply going to return an app user for the time being, just to confirm that our logic is working when we check the password. So below our HTTP post for registering, we'll add another HTTP post. This time we'll give it a root parameter of login, and we'll say public async task. That's going to return an app user, and we're just going to call it login. And for this one, we're going to have a login DTO. So I'll say login DTO, which we don't have yet, and I'll just call it login DTO. And we'll go across to our DTOs folder, and we'll just create a new C# class, and we'll call it login DTO. And this is going to have the exact same properties. It's going to have a username, which needs to be a string, and we'll call it username, and we'll have a prop of a string for the password. Now this is identical to the register DTO, and you might be wondering, why don't I just reuse that one? Well, later on we'll do a bit more with the register DTO. We're going to want to take more information from the user than just their username and password. So we'll keep these separate. We'll have one for register, one for login. We'll go back to our account controller, and inside here, looks like VS Code is going to need another kick. So I'll just refresh that window. And when we log in, the first thing we need to do is get a hold of our user that's inside our database. We need access to the user for the password hash and the password salt. So we need to go and get the user first of all. So we're going to say var user equals and await context.users, and we'll use a method here other than find, because find is good for if we know the primary key of the entity, but our username, which is what we're going to use to find our user, is not a primary key. So we need to use a different method, and there's a couple of different options for this. One's called first or default async, which returns the first element of a sequence, or a default value if the sequence contains no elements. Now we're trying to get an app user from our database. The default value for an object, our app user, its default value is null. So if we try and find a user that does not exist in our database, then we're going to get null as the response. If we do find the user in our database, we're going to get the user back. And if we use first instead of first or default, then we're going to get an exception if the user does not exist in our database. So the better one to use is first or default, so that we get a default value back rather than an exception. And another option we can use is single or default. And this one returns the only element of a sequence or a default value if the sequence is empty. And the difference between this one and first or default is if there's more than one element in our database that matches our query, then it throws an exception. In our case, our usernames are all going to be unique, so we can actually use either one of these. It doesn't really make any difference. I'll go for single or default async, and then we open parentheses, and then we enter our query about what it is we're trying to find. So we'll use the little shortcut and just say x goes to for our lambda expression, and we'll say x.username is equal to logindto.username. And that's going to go and get us our user. Now, because this could return null, a user might try and log in with a bad username. We need to check to see if we have a user before we move forward. So to do that, we'll use a conditional operator, and we'll just say if the user is equal to null, then we're simply going to return unauthorized. If their user does not exist in our database, then they're going to be unauthorized. And I'm getting an error here because I'm trying to use an HTTP response, but I haven't wrapped my app user in an action result. And that just gives you an example of why we need to do such a thing. So I'm going to say action result of type app user. And then we get access to return unauthorized. So we have our user if we move past this conditional. And then we need to check our password. Now our password has been hashed and salted with this randomly generated key. And we just need to go in reverse to what we did before. We can pass in our compute hash function the key so that it generates the same hash that it did when it initially created the password. So a combination of this key and this method will give us exactly the same hash of our password that it created in the first place. So the difference between this one, we're going to use the same line of code effectively, and this time we're going to use the key that was generated that's saved into our database to get the exact same hashing algorithm that was used when we passed in the same password. So in this case, we need to specify user.password_salt as the HMAC key, and then if the password is the same, then our hashing algorithm is going to be absolutely identical. And then in order to check if the user's entered a valid password, we just need to compare the two results. Now, this returns a byte array, so we need to get the hashed version of this password, and with this one now that we've passed in our key, we can save our computed hash equals, we can then say HMAC compute hash again, and we can pass in the same encoding, so we're going to say encoding UTF-8 and get bytes, and we can pass in our login DTO.password. So now we have our computed hash. We've got two arrays to work with. We've got our user password hash, which is a byte array, and we've got this computed hash, which is a byte array, and now we just need to compare them. And we can use a for loop for this, so that we're going to loop through each element of the byte array and compare it with the corresponding element of the other array. So we'll say for int I equals 0, and then we'll say I, and then we'll say is less than the computed hash dot length, and then we can iterate over it using I++. And we'll use an if statement, and we'll say if computed hash, and then the element at index of I is not equal to the user.password hash at the same index, then we can return unauthorized. Because if any element doesn't match, then of course that means the passwords are not equivalent. And we can add some text into this, and we'll just say invalid password in the unauthorized thing that we're returning, and in the one above we'll just say invalid username, just so we can see the different errors we get back from this. And if they make it past this for loop, then we know that the passwords match, and we're going to return the user. And we should be good, there's no errors inside there. So let's go take a look and see if this is working. And we need to check with a valid user. I don't know if Bob is a valid user actually. I think not. I don't think Bob has a password, but I know we created a user called Dave earlier on who does have a valid password. And let's just send this and see if this works. And we get invalid username. Let's just get our users and see what we do have, because I'm sure I created someone called Dave earlier on. But he didn't make it into our database, so we need to use a user that does have the password hash and salt. And I'm going to use Sam. And let's just say login as Sam in this case, and I'll press send, and we get success. We get our user back. And if I say an invalid password, I just take a character out and send, then we get invalid password. And if I put that back in and I say Sam1, then we're going to get the invalid username again. So our login functionality is working. But we cannot log in with this information to our API server. We need something that our API server can authenticate against so that it can trust the user that's apparently logged in. And in order to do that with an API server, we need to take a look at an access token, and we're going to take a look at JSON Web Tokens as our method of authentication, and we'll take a look at that next. So what we're going to discuss now is how we authenticate to an API, because an API is not something that we maintain a session state with. We simply make a request to our API and it returns data to us, and then our relationship is finished with the API until we need to make another request. Now, tokens are a good thing to use with an API because they're small enough to send with every single request. And, well, let's take a look at what they actually are. So, JSON Web Tokens are an industry standard for tokens, suggested in RFC 7519 if you're into that kind of thing. They're self-contained and they can contain credentials, they can contain claims, and other information if you want to do so. And if we take a look at the structure of one of these, what they are, they're basically a long string that's separated into 3 parts. Each part is separated by a period. Now in the first part, that's the header of the token, and this contains the algorithm and the type of token that it is. Now the algorithm is what's used to encrypt the signature in the third part of the token. And the type of the token, of course, is going to be JWT, which is JSON Web Token. Now the second part in this token is the payload, and this is where we can contain information about our claims and our credentials. So we can have things like the name identifier, what the username is, what roles the user's in, and any other claims that the user has about themselves. When we say claims, we really mean that a user is claiming to be something. So in this case, Lola, or this user, is claiming to be Lola. And we also have 3 timestamps inside there as well. The MBF means that the token cannot be used before a certain date and time. We have an expiry date and time for the token, and also when the token was issued at. And as I mentioned in the third part, well, this is where the signature is contained, and this signature is encrypted. And the token is encrypted, or the token signature, I should say, is encrypted by the server itself using a secure key that never ever leaves the server. And the only part of the token that is encrypted is the signature. Everything else is very easily obtained simply by decoding the token, which we don't need to do anything clever with. It's just very simple to get information out of a token. What we cannot do easily is modify the token in any way and expect our API to accept it, because that will change the entire structure of the token and the signature would not be verified. So let's take a look at how token authentication works. So a user logs in and sends their username and password up to the server. The server will validate their credentials and return a JSON Web Token that the client will store locally on their machine. Typically, we often use browser storage to hold onto the token so that we can then send the JSON Web Token with every single request. So anytime that we want to access something that's protected by authentication on the server, we send up the JWT token with that request. Now, what we do with this token is we add an authentication header to the request, and then the server will take a look at the token and verify that the token is valid. Now the server that signed the token will have access to the private key that's stored on the server, and the server is able to verify that the token is valid without needing to make a call to a database. And in the final part, the server says, yep, that token's okay, and sends back the response. So similar benefits of using JWT. There's no session to manage. All JWTs are self-contained tokens. We don't need to manage sessions. We just simply send up the token with every request, and because they're very small and lightweight, this doesn't add much to our request that we send over the wire. They're also very portable. We can use a single token with multiple backends. So long as the backends all share the same signature, the same secret key, then they can all verify that a token is valid. Also, no cookies are required, which means that JWT tokens are mobile friendly. Mobile phones do not deal with cookies, whereas they can deal with a JSON Web Token. And performance. Once a token is issued, there is no need to make a database request to verify a user's authentication. So a user logs in, we issue them with a token, they keep hold of the token, and anytime they need to access a protected resource, they present their token inside an authentication header, and the server is able to verify the token without needing to check the database or the user is who they say he is, because the token is a trusted thing, and if a user has a claim in there saying that this is their username, then because it's inside that token that's been signed by the server, then it will trust that that username is the user that's accessing that resource. So let's go ahead and implement them in our application. So now we've got our methods for register and login. We need to be able to issue the users with one of those tokens we've just discussed. And we're going to create a service to do this. Now, so far, if we take a look at our program class, we've just been using services that have been provided by the framework or entity framework. And this time we're going to create our own service and add it to our services container so that we can inject our own service into the controller or our account controller, so that when a user logs in, we can issue them with a token that we get from this service that we're about to create. Now, when we create a service, typically what we'll do is we'll create an interface which tells the implementation of the service what methods it supports. And I'm going to ask you to do this now without really fully appreciating the reason for doing so. But we'll go ahead and do it, and then I'll explain as we go through. So in our API folder, let's create a new folder, and we're going to call this one Interfaces. And we're going to create an interface. And bear with me on this as I create it, and then we'll explain as we go through. So I'm going to say new C# interface. And conventionally, interfaces in C# are prefixed with the letter I, capital I, and we're going to create a token service. And this service is going to support, I'll just remove the unnecessary usings, is going to support a single method. We're going to specify that we want to return a string, and we're going to call our method createToken. And we're going to pass in as an argument the app user and call it user. Now this interface you can see as a contract. Any other class that implements this interface has to support this method. And it has to return a string from that method. And it has to take an app user as an argument. It's like a contract between our interface and our implementation. Now, to continue this, we'll go and create another new folder in our API. And this one we'll call Services. And inside our Services folder, we'll create a new C# class called Token Service. And inside here, we'll remove the unnecessary usings, and then we're going to tell our token service that it's going to implement the iToken service interface. Now when we do this, we get an error on the interface, and if we hover over the error, then it tells us that token service does not implement interface member iToken service createToken. Now that's the only method that we have inside our interface. And in order to abide by the contract that we have between our interface and our token service, we have to provide the method. And we can do that by using the quick fix and then saying implement interface. And it creates the boilerplate for the method that we need. Now, in the next lesson, we'll go ahead and add the logic and all the things we need to do inside this class. But for now, we'll just go back to our program class and add it to our service container so that it's available for injection elsewhere in our application. So we'll go to the program class, and as I mentioned before, where we put this doesn't really matter. So I'm just going to add it below and say builder.services, and then we've got options about the lifetime of how long do we want this service to be available for. Now there's three options here. There's add transient, and this is a very short-lived service, so the token service would be created and disposed of within the request as soon as it's used and finished with. Now for any services that we create, even though that probably would work just fine, it's always considered a little bit too short-lived for what we're doing. We're dealing with an API controller and HTTP requests. When we create a controller, as in a request has hit the endpoint, so the framework instantiates a new instance of that controller. The controller looks at its dependencies, or the framework does, and says, aha, I need to create these services and create new instances of these services when the controller is created. Now, when the controller is disposed of at the end of the HTTP request, then any dependent services are also disposed. And the way that we get that behavior is to use add scoped. And that's then scoped to the HTTP request. And in the case of add transient, then that would be created and disposed of as and when it's used. And you might think that's more appropriate, but it is really considered too short-lived for an HTTP request service, which is what we're using this inside of. Like I say, it'd probably work, but it's more standard to use scoped for an HTTP request service that we're using inside a controller. The other option that we have is a singleton. And we could create a service that's instantiated when the application first starts and is never disposed until the application has closed down. Now, again, in this particular example, that would work just fine. But then we'd have a service hanging around in memory that we're not actually using on a consistent basis. We only need the token service when we need to create a token, and we don't need to have that token service residing in memory for the entire length of the application lifetime. So the most appropriate one to use is add scoped in most occasions. And there's special occasions where you might want to use a transient or you might want to use a singleton. In the case of a singleton, a good example for using that is if you're using a caching service and you want every single request that comes into your API, you want to save the response from that request into your cache so that the next request from somebody else could go and take a look in that cache and retrieve the cached data, which is a great way of improving performance of your application. We're not covering that part, we're just dealing with our token service right now. So inside this angle bracket, we need to provide two things. We need to provide the interface, which is the iToken service. And if we provide an interface inside here, then we have to provide its implementation class as well. So we'll specify token service and then close the parentheses. Now you might be wondering, can I just create the token service and use this as a service? Yes, you absolutely can, and that would work just fine. But the advantage of using an interface is when it comes to testing our code. Now, we're not including testing on this course, so it's difficult for you to appreciate the usefulness of using an interface. But if you did decide to add testing later, then it's so much easier to test when we're testing against interfaces and isolating our code. Because if we go back to we're going to inject this into our account controller. But when you want to test a controller, you need to create a new instance of that controller. And that means you need to provide any arguments that are inside its constructor. So you'd have to provide an implementation of the data context. And if we added the token service and not the interface here, then you would also need to provide an implementation of the token service. And the idea of testing is that you isolate what you're trying to test. And if we were testing this register method, we would just want to know the outcome of what happens when we pass it a register DTO. Do we get the correct response? We don't normally care about all of the implementation stuff going on inside, and we'd want to test those parts individually. But then would we really want to test the entity framework methods? Well, no, that's not our code. That's somebody else's code that's already been tested. And all I'm saying really is that using an interface, we can mock the implementation class. We don't have to implement it. And there's different strategies for dealing with a data context. And we'll also look at that a bit later on in this course about how we get around using an interface of our own instead of using the data context in our classes directly. But that's all coming later. I just wanted to mention why we're using an interface, and it's best practice to do this by default. Even if you know right now, this very minute, that you're not going to be testing your code and writing unit tests, it's always useful to just create the interface anyway. It's very quick and easy to do, and in our service we have the ability to specify the interface and the implementation class as the service, and when it's needed, the framework will take a look at this interface and then create an instance of the implementation class. So I'm asking for an element of trust that this is typical behavior for a developer when creating a service, to create an interface and an implementation class at the same time. it will save you time later if you decide to add testing to your application. So now we have this token service, we need to take a look at the implementation and the logic inside here, and we'll take a look at that next. So in this lesson, we're going to take a look at our token service and the logic that we need to add in this method to be able to create one of those JSON web tokens that we can then return to our clients. Now we're going to need some help with this, so we're going to need a package that we get from NuGet. So first of all, we'll open up the NuGet package manager, or NuGet gallery in the case of VS Code, and we're going to search for system.identityModel, and we need this one, system identity model tokens.jwt. The version of this is not particularly important. I'm just going to select the latest one and install it into the api.cs proj file. And that's going to go ahead and do its thing. And once it's complete, we'll just close the terminal. And we'll make use of this package in our token service. Now, inside this service, we'll create a constructor. So we'll say CTOR. And we're going to store our super secret key that we're going to use to sign our token. We're going to store that in our configuration. And in order to get our configuration and inject it into this service, then we need to inject iConfiguration, and we'll call it config. Looks like my auto importing is not playing, or it's a thing that we don't need to add a using statement for because that's covered in the implicit usings. And above the constructor, we'll create a field and we'll call it private read only. And we're going to specify symmetric security key that we get from Microsoft Identity Model Tokens. And we're going to call it _key. Because it's a private field, we'll stick with that convention. Now, a symmetric security key, there's two types of keys really used in cryptography. There's a symmetric key where the same key is used to encrypt the data as is used to decrypt the data. And since our server is responsible for both signing the token and decrypting the token, or the token key I should say, not the token itself, the token is mostly in clear text apart from the key that it's signed with. That part's encrypted, the rest of the token is not. And as far as our API server is concerned, it only cares about whether or not the token's been modified, and it's just going to read the information from it. If it has been modified, then it will reject it and say unauthorized. We'll experiment with that as and when we've got a token to work with. The other type of key is asymmetric, and that's when your server needs to encrypt something, and the client also needs to decrypt something. And on that basis, we have a public and a private key. The private key stays on the server, but the public key can be used to decrypt the data. And that's how it works with HTTPS and SSL. We have a public and private key. In this case, we can just use a symmetric security key because this is going to stay on the server and never go to the client, because the client does not need to decrypt this key. And then we can set this key, and we're going to say key equals new system or symmetric security key, and then we need to encode this into bytes because our symmetric security key takes a byte array. So once again, we need to use that encoding, and then we'll say UTF-8, and we'll say get bytes, and we're going to specify our config, and in square brackets, we're going to access the key, and in this case, when I refer to key, it's going to be a key and value pair. And when I'm talking about key value pairs, if I just go to our app settings, then what we have here is a key and a value. And that's what we're referring to when we're getting something from our config. And we're just going to call it token key. Now, we don't have this yet in our config, but we will do. Now, when it comes to creating the token, inside our token, we want to include something referred to as claims. And let's just create this, and then I'll explain what I mean by claims as we go along. So we're going to say var claims equals new list of type claim. And inside here, we're going to specify new claim. And the claim has got a set number of standards that it uses, and we can use JWT registered claim names, and then we can specify that we want our name ID, and we're going to set this to user.username. Now a claim in usage like this is a claim about, in this circumstance, a user. So I might claim that my name is Neil, for instance. I might claim that my birthday is the 10th of May. I might claim that I support Arsenal Football Club. And they would all be claims about myself. And I don't need that semicolon there. I need it there. So a claim is something, a bit of information that a user claims. And in this case, we're going to set our claims to the username. Now we're adding a list of claims because we can have more than one. And it's desirable a bit later on for us to have additional claims. So we'll create them initially as a list of claims even though there's only one. And our user's going to have a token that claims their username is what it's set to inside the token. And we're going to use that username for many different things, especially when it comes to checking a user is who they claim to be. So next we need some signing credentials, what we're going to sign this token with. And we'll save our creds equals new signing credentials, and we're going to pass in our key as the first parameter, and the next parameter is what algorithm do we want to use to encrypt this particular key. So we're just going to say security algorithms, and then we're going to specify HMAC SHA, and we'll just go for 512 signature, the strongest available in that list. Next part is to describe the token that we're going to return. So we're going to say var token descriptor equals new security token descriptor. Inside here we specify a few properties. We need a subject, and the subject is going to include the claims that we want to return. So we'll say new claims identity and pass in our list of claims, even though it's only one. We also need or can add an expiry for this token. Now we're going to set this for 7 days. Typically this would be a much shorter value, but we're just in development mode and we're making sure our application works. So we're just going to say add days and 7. So that means our token will expire after a week, and at that point we would need to log in again to get a new token. And then we pass in the sign-in credentials and we'll set that to the creds that we created up above. After we've described what our token is going to include, we need a token handler. So we'll say var token handler equals new JWT security token handler, and this is the part we get from identity model tokens or system identity model tokens JWT, the package that we installed. Then we can create our token, so we'll say var token equals token handler, and then we can use its create token method, and we can pass in the token descriptor which includes our claims, etc. After that we can then return the token, so we'll use the token handler once again, but this time we're going to write the token and pass out our token. And we're not getting any complaints from here, but I am getting a complaint from something up above. And JWT registered claim names is an ambiguous reference between Microsoft Identity Model JSON Web Tokens and System Identity Models JWT. In other words, I've got two using statements at the top that both have a method in them called JWT registered claim names. I don't need both of them. I can remove the Microsoft Identity Model JSON Web Tokens. We only want what we're getting from System Identity Model Tokens JWT, and we should find that that error has now gone away because we don't have the additional using statement that caused that particular problem. So we're all good. Now we've got our method to create a token, and next we'll take a look at how we can return a token to a user and make sure we have what is a valid JWT. Okay, now we've got our token logic. Let's go ahead and do what we need to do so that we can return this token when a user logs in or registers. In order to do this, we'll create a new DTO, because currently we're sending back all of this information when a user logs in or registers, and obviously we don't want that. And this is a good time to use another DTO. And we'll create a class called user DTO. Inside here we'll do the normal and get rid of anything we're not using. And just two properties inside here. We're going to have a string for the user's username. Now at this point, I'm returning everything with username how I like it to be specified, the user uppercase U and lowercase n. And I'd normally encourage you to be as consistent as possible with casing, but in this case it doesn't really matter. We can return our data how we want it, and in my case I want it to be username as it's spelt that way, or in casing that way. And I'm going to return the string of the token. So that's what we're going to return. So we'll go back to our account controller, and we've got something else now we need to inject into this controller. So we'll specify the I token service, not the token service. We're using the interface here, and it's the framework's job, based on what we've specified in our service container, to look at what implementation is being used for the token service. And like I say, if we were including testing, then this would be very easy to test, because instead of using the implementation that we have inside our actual application, if we had a test project, then we would use a mock of the implementation class, and we would just return a random string that represents a token instead of actually creating a JSON web token, because we would not be interested in testing that part. We'd be interested in testing the controller method, for example. So we'll use the initialize field from parameter, so we've got this available. And then we'll scroll down to where we're returning our user. And in fact, instead of returning an app user, we're going to return the user DTO. And in the return statement, which is now showing an error because this is not currently a user DTO, we're going to say return new user DTO. And we'll open curly brackets below. And we can specify the username equals, and we'll get user.username. And we'll specify the token is equal to the token service and create token, and we just need to pass in our user, and close this with a semicolon. And we'll also do exactly the same for our login method. We'll just copy that and paste it inside here, do a bit of reformatting, and we need to adjust the app user and change that to user DTO. And good, no errors, no problems, everything's good with what we've done there. Now inside our token service we have a configuration entry, and we need to supply that in our configuration file so that this token key can be read from our configuration. Now normally I would say this is a secret key, it should go in your app settings.json, but for development we're going to have a development token key. That's just easy for us to read and understand. So I'm going to specify a configuration of token key as the key, and the value, well, I'm just going to say super secret unguessable key as the string for the key. Now obviously in real world scenario, and please bear in mind this is our development version of our application, this would not go into production. In production I'd probably have a string of random characters of 32 characters in length that's literally impossible for anybody to guess. But for our development version of this application that's going in the app settings development.json, then we can put whatever we like in here. The only rules on this, I think this key needs to be at least 12 characters. So try not to use just secret on its own, otherwise that won't work. It does need to be a minimum length, so go for something like I've done that's at least more than 12 characters for your token key. Now that we have this in place, we should be able to test that our code is working. So we'll go across to Postman and test the output of our work. Let's see what users we're working with just now. And we've got Sam, we've got Jim, and we've got Sarah, and blank username. We'll obviously need to clean out the data from our database because we've got some users that don't have passwords, we have some that do, and our data is all a bit inconsistent. Don't worry about that for now, we will clean this up very soon. I'm just going to go for Sam as the user I'm going to log in as, even though this says login as Bob. It's already updated to be logged in as Sam. So let's go and execute this request. And this time we get our username and we get the token back. So let's copy this token into our clipboard, everything apart from the quotes. And we'll head over to our browser, and we want to go to a site called jwt.ms. And this will allow us to paste in our token and see what's inside it. So I'll enter the token below, I'll just paste it in. And we can see that we've got the decoded token, and the signature we cannot read, because this is a client, it's not our server, we don't have the symmetric security key available inside here. So we've got the claim, which is the name ID, which we set to Sam, and then we've got some information about not before, when is the earliest this token can be used, when does this token expire, and when was it issued at. And if we take a look at the claims, then there's not much to see here. We could just see the things that are inside our token and the information about the dates I was just referring to there. So now we have our token, we need to take a look at how we can actually use this, and that's coming up next. Okay, so our users now have shiny new tokens to use to authenticate to our application, but how do we go about doing that? So let's take a look. We'll head back to VS Code, and first of all we'll go to our users controller. In fact, let's open up the account controller and we'll open up the users controller. Now, in order to ensure that only authorized users can access a specific endpoint, then we can specify that we want them to authorize to it, and we could do that via an attribute. So just above the get user, for example, and this is just a simple example, for demonstration purposes, we can specify the authorize attribute here. Now, if a user wants to get an individual user, they'll only be allowed to if they pass up to us or our API server an authentication token. And in our case, that's going to be a JWT. Now, we could do this at a higher level. We could say that for all of the endpoints inside this controller, we want to authorize every request. And then let's say, for example, for whatever mad reason we decided that we wanted get users to be allowed for anonymous users, then we could say allow anonymous for this particular request. And then of course, because we've got authorize at this level, then we would not need authorize at that level, because it's going to take what's specified at the top and use that. Now, what you cannot do is use allow anonymous at the highest level, like this, and then override it with authorize here. This authorize would be ignored if you specified allow anonymous here. And the reason is, I'm just going to go to the documentation and point out the warning inside here. And allow anonymous bypasses all authorization statements. If you combine allow anonymous and any authorize attribute, the authorize attributes are ignored. For example, if you apply allow anonymous at the controller level, any authorized attributes on the same controller or on any action within it are ignored. So we don't want to do it that way, is what I'm saying. If you're going to do something at a high level, use authorize at the top and then allow anonymous further down where you do need to provide allow anonymous. And we'll take off the authorize on the get user. We don't need it there because we've got it higher up. So that's as simple as it is to specify that you want your endpoints to be authenticated against. But we need to tell our server how to authenticate. And to do that, we need to go back to our program class so that we can set this up. So there's two parts to this. There's a service that we need to add, and there's middleware we need to use so that as our request comes in, the request can be inspected, and then the framework can decide whether or not to let the user proceed based on their authentication token or otherwise. And because it's middleware, if we try and access this request that comes under the authorize attribute, if we try and access this, then because there's middleware applied at a level prior to the request getting to our endpoint, then we will not even reach the endpoints that I've highlighted here. So in our program class, let's set up the service, and like I say, this part should not matter where we put this. So I'll say builder.services, and we're going to say add authentication, and we're going to specify the type of authentication scheme that we're going to be using inside this parameter. And the authentication scheme we're using is called JWT bearer defaults. And if we use the quick fix, then this suggests that we need a package to make use of this. So we're going to need to go to NuGet Gallery once again, and we're going to need to search for, in this case, Microsoft.ASP.NET Core.Authentication, and we need authentication or Microsoft.ASP.NET Core.Authentication.JWT-bearer. That's what we need to be able to use that particular statement. So I'm just going to click the API and install this and close the terminal. And if we go back to the program class and we put our mouse cursor inside the error, what we should find is that now we can use that package that we've just installed. So I'll go ahead and add this so that it comes up at the top. And then we specify a period after that and say authentication scheme. And then we need to chain on after this. So just on the next line, I'll just add a period and we're going to say add JWT bearer. And then we specify some options for this method. So inside the options, we're going to say options.token validation parameters equals new token validation parameters. And inside here, we can specify all of the rules about how our server should validate this token as a good token. So we're going to say we want to validate the issuer signing key. This means that our server is going to check the token signing key and make sure it's valid based upon the issuer signing key, which we'll specify next. So we're going to say true. We definitely want that. Otherwise, it won't check our token has been signed by the issuer. And that means anybody can make up any random token. As long as it's a JWT, then our server would accept it. So this is essential. Then we need to specify what our issuer signing key is. And we're going to say our issuer signing key is a new symmetric security key. And then we need to get the bytes of our key. So we're going to use encoding once again and say UTF-8. And we're going to say get bytes. And then we need to go to our configuration to get the token key. So we're going to say builder.configuration, which we have access to inside here because it's our program class. And then we're going to specify the exact same key that we used in the token service. And everything's going a bit too far across for my liking. So I'm just going to bring that down so we can see everything on the same page. So once again, just the usual string warning. If you call this token something other than token key and make a typo, it's not going to work. So do be careful when we're using strings, especially when it comes to getting something from our configuration. A couple of other things we'll just add in. We're going to say validate issuer equals false. The issuer of the token is of course our API server, but we'd need to pass that information down with the token in order to validate it. We don't have that, we haven't implemented that, so we're just going to say that's false. And we're going to do the same for the audience and set that to false as well, because that's information that we have not passed with our token. So with these elements in place, this gives our server enough information to take a look at the token and then validate it just based on the issuer signing key, which we have implemented. Now, in order for this service to be used, we need to add the middleware to authenticate the request. Now, the positioning of this is important. In fact, let's just move this down as well, just so it's visible. But we need to add the authentication middleware before the map controllers method and after use cores. So very specifically, we need two bits of middleware here. We need app.use authentication, and this has to come first, and then we say app.use authorization, which comes second. And these two pieces of middleware ask two different questions. The authentication part just asks, do you have a valid token? And the authorization part says, okay, you have a valid token, now what are you allowed to do? So think of authentication as you going into a nightclub when you're under 18 and presenting your ID card that says you're 16 to the bouncer on the door. And he looks at your ID and he ascertains that, yep, that's valid ID. But that doesn't mean you're allowed in the nightclub. In order to be allowed in a nightclub, you have to be over 18, so we'll look at the date of birth and say, yeah, you've got some valid ID, but this doesn't authorize you to enter the nightclub. So we do need those two specific parts to this. Now, in our case at the moment, as long as a user's authenticated, then they can go to an authenticated endpoint. So with our middleware in place, we should be able to test those few methods where we are specifying we need somebody to authenticate against the endpoints. So let's go and test that theory. And if we go to section 4, I'm just going to log in as not Bob, I'll log in as Sam and get another token. And click send, and I'll copy the token into my clipboard, first of all. Now we've got two requests here, get users, get user. The get users one, we allowed anonymous access, so we've got no authorization going on inside here, and if I click send, this one should work. On the next one, again, without any authorization, if I click send, I get 401 unauthorized. In order for our client application to authenticate to our API server, then we send up the token along with an authorization header. In order to do that, we need to specify a key, and we need to use authorization. And then in the value for this key, very specifically, we need to specify bearer, spelt exactly like that, B-E-A-R-E-R, followed by a space, and that space is essential, and then we'll just paste in the token that we've got in our clipboard. Now if we send this request, then this one should work just fine. We've authenticated against our endpoint, it's let us in, and it's returned the data. And the user that we're requesting here was Bob, and that's user number 1, and he doesn't have the password hash. Now supposing you wanted to trick our API server, because these tokens, if I go back to the browser and we go back here, we can see that our information is in clear text. Now if we go to a slightly different site to decode our token, let's say jwt.io, and we take a look at this one, and inside here, let's just paste in the token again. Now this one gives us some verify signature information. We'll ignore that, but we can update this one. And let's supposing I thought I'd try and beat the server and say instead of my name ID being Sam, I changed it to Bob, and then added in an evil laugh and say muhahaha, and then take this token that's been updated with the new data. Now this token is specified as Bob, and if I paste it into the other utility we were using and go to the decoded token and paste this in, now we can see the name ID as Bob. And if I try and take this token and I go back to Postman and let's paste this in as the bearer token, overwrite all of that and replace it, now we've got a token with the name ID as Bob. Is this going to trick our API server? No, of course not, because the signature, it's not possible for us to fool our server into believing that token, because when we modified the name inside here, then notice what it does to the signature. Let's just go back. Then when we modify the name, then this part in blue is also modified, and our server isn't going to trust it. And that's the reason that we got a 401 unauthorized. So we're almost finished with this section. We've got a short lesson coming up just to deal with a bit of housekeeping, and we'll take a look at that next. So we've got our basic authentication implementation in place, and just to finish off this section, we're going to take a look at using extension methods for two reasons really. One, just so that we see what extension methods are and what they do for us, and the second reason is to do a bit of housekeeping inside our program class, the main entry point for our application. This can get quite busy as we add additional services and we add various middleware into this particular file. So we'll take the opportunity at this early stage to move out things from this particular file and put them inside extension methods. Now extension methods allow us to extend a class in some way, and that class can be one that we write or it can be one that's provided by the framework. Now the class that we're going to extend is this services class, which is of type iService collection. And this is going to allow us to take our existing services, put them elsewhere in a separate file, and then we'll come back into the program class and see how we use the service extension. So it's just really a bit of housekeeping that we're going to do now. But inside Solution Explorer, inside the API folder, I'm going to create a new folder called Extensions. And inside here, I'm going to create a new class called Application Service Extensions. And let's go ahead and create our extension method. We don't need any of the noise at the top. And to create an extension method, we need to make this class static. And when we make a class static, that means we can use the methods inside it without instantiating a new instance of this class. We can just use it. And inside our static class, we'll have a static method, and we'll say public static. And we're going to be extending the iService collection, but we also want to return the iService collection. So we'll specify that as what we're returning. And we'll just call this method add application services. Now we need to specify the thing that we are extending. So we use the list keyword to do that. And it's going to be, and we're extending the iService collection. And we'll call it services. We can also pass arguments into this, and we're going to get our iConfiguration and call it config so that we can also use that inside here as well. And let's move this down so it fits on the screen. Now we have access to the services inside the iService collection, and if I specify services, then we've got all of the same services available that we could have added in the program class, things like add cores, add DB context, etc. So what we'll do is we'll go back to our program class. We'll just copy what we want to add. I'll leave the add controllers in there, and I'll just copy everything else or cut everything else into the clipboard and go back to the application service extensions and paste that in and try and reformat it, which it didn't do a very good job of, so I'll just move that across. And instead of builder.services, we just need services, and same for this line, and same for the line below. And we just need to add the using statements for anything that's missing. So we need api.data. We also need the entity framework core. And instead of builder, we're going to be using the config that we're passing in as a parameter. So we'll say config, and then we just need to bring in our interfaces, and we need to bring in our service API services namespace. And because we're returning an iService collection, we need to return services. And everything's good inside here. So in order to use this, then we go back to program.cs, and we can say builder and services. And because we've extended this with our own extension method, what we should find we have access to inside here is our add application services method. And we'll open parentheses, and it tells us that we need to pass through the config as well. So we can say builder.configuration as what we're passing through to the application services. And we'll also do the same for identity related services. It's not too busy at the moment, but it could do later on when we take a look at ASP.NET identity. So we'll do the same thing again, just a bit more housekeeping, and we'll right click our extension folder, and we'll create a new C# class, and we'll just call this one Identity Service Extensions. Inside this class, once again, we'll make this a static class. We'll remove the stuff we're not using, and we'll create a public method, a public static method, that's going to return an iService collection once again, and this one we'll just call add identity services. Once again, we specify this iService collection as the thing that we are extending, and we'll specify services, and we also need the configuration for this as well, so I'll just say iConfiguration and call it config. And just drop this down. And we'll go back to the program class, we'll just cut this code and paste it inside here. Try and reformat. And we're going to take out the builder.services and replace it with services, and just bring in anything that we need. for this to work, which is probably a few things. And encoding comes from system.text, and instead of builder.configuration we have config and the token key. And then we can just go ahead and return our services. And to make sure our code is clean and good and we've got no errors, we'll head back to the program class, and then we can just say builder.services, and we can say add identity services, the one that we've just added, and we pass in builder.configuration once again. And this makes our program class a bit cleaner, and it's quite a common thing to do when building a .NET app. Now we've come to the end of this section, so that means we're going to commit and stage our changes into source control and push them up to GitHub. So let's take a look at our changes, and that all looks good. Don't worry about this database file stuff where one time it's there, another time it isn't. It's not going to cause us any problems. We've got our database file there and all of our changes inside, which all seem okay to me. So we're going to stage these changes, and we'll say end of section 4. And then we can commit them, and we can sync the changes, and we get the warning again. I'm just going to say, okay, don't show again. And that's going to push these changes on up to GitHub. And I'm going to take the opportunity to say no to periodically run git fetch. And we'll wrap up this section with a summary. So we've reached the end of section 4, and let's just wrap this up with a summary and take a look at our learning goals for this particular section. Now we've gone ahead and we've implemented basic authentication in our app, and hopefully we've got an understanding now of how to store passwords in a database. Now, I often get questions from students about this, certainly around the sorting and the hashing of the password. Now, hashing the password is good because it's a one-way operation, and it means that our password cannot be read in clear text. But it's not good enough because there's 1,000 different dictionaries out there of all common passwords and every possible password combination that's already been hashed using multiple different algorithms. So it's very easy to take a hash and find out what the original password is from these dictionaries. Sorting protects us against that, but it doesn't solve everything. It does protect against general dictionary attacks on a password, but it doesn't stop a concerted attack on a single password. It just protects people who have the same password on multiple machines, but it certainly doesn't make poorly chosen passwords any better. But we do have passwords stored in our database that are not in clear text, and we do solve that one problem of protecting against general dictionary attacks. Having our database compromised is still a very bad thing, and we would still need to tell all of our users that we've been compromised and they need to change their password everywhere they've used it. What we've also taken a look at is using inheritance for our base API controller, and this prevents us typing out repetitive code. So it's that do not repeat yourself thing. We've also taken a look at using the C# debugger, and this can help us see what's going on with our methods step by step. We can see what values our variables have at any given time during a method. We've also taken a look at data transfer objects and how we can shape the data that we both receive and also what we return to the client. We then took a look at validation and made sure that we had required attributes on our DTOs so that we don't take up bad data. And we've also taken a look at JSON Web Tokens, these little tokens that we're going to send up with every authenticated request that we need to make from the client. And as I mentioned, we don't need to call our database to check that the token is valid, because the API server is going to verify that it's a valid token based on the signature that it's signed it with. And we also took a look at using services in C# to help us generate the token. And this keeps our code clean because the service, our token service, it's just got one job. All it needs to do is generate a token. It doesn't need to authenticate the user. It doesn't need to do anything like that. It's just got a single responsibility of receiving a user and then returning a token. That's all it does. And we also took a look at adding the authentication middleware, and please remember the ordering of that is always important. And then we took a look at extension methods as well, just to tidy up our startup class and keep our code clean. So now we've implemented this in the API, what's coming up next is what we're going to do in the client regarding login and registration.